Compositr is a system that solves the problem of scorekeeping. Imagine you're running an engineering design competition, perhaps for the Scouts, or for KU Engineering Expo. In such competitions, we have numerous events. With Engineering Expo, for example, each student organization has their own event in which students compete and are ascribed a score. Complications occur when each organization has their own scoring procedure. Data and scoring procedures are then scattered across numerous spreadsheets, rubrics, and formulae. Collecting scoring information for each of your teams across all the competitions can become a time-intensive task of administration. Imagine instead, we had developed a web application backed by a data store that allows each organization's scorers to enter scores. There may be two ways to enter these scores. In one simple method, we can imagine that the Expo administrators had decreed that every reported score must be an integer between 0 and 100. While this makes it easy to record scores, it doesn't really save us much time. Each student organization that scores teams still runs raw data through formulas to compute their scores. In the second method, we can imagine that we have collected descriptions of each organization's scoring formulas, and we've written custom code that will transform raw data into actual scores. But from experience, we know this can actually be quite difficult. What if scoring procedures were to change? What if a student organization creates an entirely new event with an entirely new scoring procedure? Code quickly becomes deprecated and unmaintainable. How then can we develop a method of scoring for any type of procedure, for any type of competition? This is where Compositr comes in. Compositr's key insight is that every scoring procedure can actually be represented as a flowchart. When a scorer enters data about the competitor into their Excel sheets and then applies a formula, they are really applying a series of simple transformations on incoming data to produce final scores. The language they use to devise scoring procedures is really quite simple, usually consisting of simple arithmetic and relational comparisons. Compositr gives you a way of describing scoring as the transformation of data as it flows naturally through the blocks of a flowchart. Let's look at some examples. In a scoring procedure that averages several presentation scores, we can imagine that when we enter the three scores, the data comes in from the left. It then flows through an averaging block, which computes the final average score. Representing many types of scoring procedures then becomes quite straightforward. Let's imagine we had devised an engineering vehicle design competition. In this event, we require that the vehicle's weight and volume ratio meet a certain specification. Then we race them downhill and record the times. This flowchart captures precisely that logic. If the vehicle meets specifications, we take their race time. If not, we ascribe 0 as the score. Let's now look at how we might create one of these flowcharts. First, we create our overall competition, which is composed of different events. We then describe the kind of data we would like to collect, as well as create. In our presentations example, we collected 3 scores from 3 separate judges, then we averaged them to produce a final score. So let's describe those data types. First, our 3 columns are integers, and let's say that the rubric that describes the competition caps each individual score to 5. Since we have an average, the final score will be a decimal number from 0 to 5. We've also provided some comments that will appear to scorekeepers when they submit raw data. Now that we've described our data, Compositr uses the information to build, on the fly, all the necessary tables for storing information related to our competition. Now we need to build the flowchart that describes how data will be transformed, that is, what our scoring procedure will actually be. The flowchart editor provides all the different blocks that describes how we might transform our data. We have blocks for different mathematical operations, such as addition, division, or averaging, comparative operations, such as less than, greater than, or equal to, as well as conditional checks that give us some control of flow control. We can also declare named constants for use in comparisons or as coefficients. Once we build the flowchart that describes our procedure, we submit it to the backend. Compositr stores the flowchart with all the relationships and position information. This lets us do 2 things. First, we could fetch the flowchart later to make changes. Second, we can use the flowchart to actually produce the code for our scoring procedure. Because these flowcharts have a linear description of data without any loops, the flowcharts themselves are actually an abstract representation of code. In particular, they are directed acyclic graphs. Compositr takes these graphs and then compiles them from their graph representation into an abstract syntax tree. The syntax tree is then interpreted by the Compositr runtime, taking in raw data and computing final scores. Let's see an actual example of this. Compositr divides the burdens of data entry into separate collections referred to as taps. Taps allow us to logically group submission fields so that we can decentralize data entry. We can divide up work by having multiple volunteers enter data to separate taps, and having a mobile app, currently just for Android, makes this work quite easy. Compositr is smart enough to know that only when all necessary data has been submitted can we compute the final scores. Let's actually submit to a tab. Here for our presentation, we select a registered team, then put in data values. For example, our 3 judges give scores of 4, 5, and 4. When we submit this data, Compositr saves it in a table, then fetches and compiles the flowchart, computes the score, and then puts the score in the table. On our web front end, we can look at the table values and finally see that our computer score is about 4.33. Also, because we previously provided restriction information, when we declared our incoming and outgoing data, Compositr is aware of what kind of data you should not be able to send. This is why when trying to submit 7, it failed earlier. This helps us stay sane and keeps our database from filling with bad data. Compositr therefore describes in a visual manner the entirety of a tiny programming language, one that is statically typed and interpreted. Because it has no iterative constructs, and because we provide type information, when the Compositr parses a flowchart, it can guarantee us that it will not store a flowchart unless it is semantically correct. This guarantees that our scoring procedures can never crash. Compositr solves our problem of scoring, and by that we mean that Compositr can express any possible scoring procedure within reason. With Compositr, we can capture the full domain of scoring procedures, produce data stores that hold the information, and code that computes actual scores. We built Compositr so that administering competitions can become easier. Other more brittle systems would constrain our competitions, enforce monotony, or simply break. Compositr lets us be imaginative so that we may design intriguing and enjoyable events for engineering design competitions, which may hopefully attract generations of younger students to the sciences.